All right, here we are, number 4 from our projectile worksheet. Now we're launching something at a much steeper angle, okay? So we're launching it at a 66-degree angle. At a force of 4.47 meters per second. Okay, so what we want to do, once again, let's break up the velocity to horizontal velocity, and that is going to be 4.47 times cosine of 66. And then let's break the component into vertical velocity. And that's going to be 4.47 times sine of 66. Okay, so I got my calculator out and put those in, made sure I was in degree mode. And it makes sense. Our 4.47 meters per second has been broken down into horizontal component that's 1.81 meters per second and a vertical component of 4.1 meters per second. Okay, so once again, we're going to go right to this y final. Let's just talk about the height. Well, that's y initial, which is 0, plus the y component, so that's 4.0, that's our velocity, 4.083t minus 4.9 t squared. Now, hopefully you've been doing the other one, but if you don't know where that came from, it came from this. I've started every problem by writing that down. Okay? So, what do they want? Well, what I need to know is how long it takes for that thing to return back to the ground. So last time I did this by hand. Now I'm just going to put it in my graphing calculator, 4.9, 4.083. So let's go y equals, see, I already have that in there. And then 4, 4. Okay, back over to the mouse mode. This thing stinks. 4.083x. Let's graph it. Okay. I mean, I could zoom in if you wanted, but look, this thing is only going to go about a meter high, it looks like. That makes sense because we're not shooting it very fast. So let's calculate the maximum. Second, calculate maximum. All we're doing is finding the vertex of this. And it looks like after 0.4166 seconds, our height will be 0.85 meters. 0.4166. See, look. 0.4166 here. That's how long it took to return. Oh, no. Time out. That's the maximum height. Time out. I got to remember what I'm doing. Let's sketch this picture. So this right here, 0.4166, comma 0.8505. Point. Okay. Well, I'll tell you right now, if it asks how long is it going to be till it hits the ground, well, that's going to be twice as long as that. It's going to be 0.837 or 33. But let me show you. Let me just show you, just to make, in case you don't trust me. Let's calculate 0. Get to the left, enter. Get to the right, enter. Enter. Come on. And notice 0.8332, 0. So that's the answer to this. How long did it take? 0.833 seconds. What's the maximum height? 0.85 meters. Okay. Well, how far did it land? Okay, we go back to distance, and the horizontal is just rate times time because there is no acceleration in the horizontal. Okay, and that's going to be our horizontal velocity, so 1.8 times the time, which was 0.833. And you get about 1.51 meters is how far it went. This is kind of like what your projectile is going to look like on your catapult project. That's about how far we're going to shoot. Actually, we want to shoot a little bit further than that, somewhere between 3 and 6 meters. This gives you an idea of what we're going to need. Hope it helps. Boom!